Hey Falcons! Today for homework, you guys are working through 3 example problems on graphing parabolas in intercept form, which is what you guys worked on in class today. So whether you have Miss McKiernan, Miss Rosso, or myself, Miss Shaw, your homework is the same for day 2. So let's go ahead and let's check our work and make sure we're good. So first off, if we have the function p of x is equal to x plus 1 times the quantity x minus 5, if we wanted to find the x-intercepts, we do want to set this function equal to 0, and we do want to solve for x. So if 0 is equal to x plus 1 times the quantity x minus 5, then each of these individual factors could potentially be 0 when you multiply to get a value of 0 in the end. So we can go ahead and set x plus 1 equal to 0. We can go ahead and set x minus 5 equal to 0. We can go ahead and subtract 1 from both sides, and we get that x is equal to negative 1. We can add 5 to both sides, and we get that x is equal to positive 5. Now, because it asked for our answers as x-intercepts, find the x-intercepts or find the zeros, our final answer is really negative 1, 0, and 5, 0. And those are our 2 x-intercepts. Now, if we want to go ahead and find the y-intercept, when you think of a y-intercept, that is always the location on your parabola where x is 0, and you're looking for where your parabola crosses at that point. It's always 0, y. So we can go ahead and set, we don't know what y is going to be equal to, or the function, so we can just go ahead and substitute 0 in for x. We can evaluate. 0 plus 1 is 1. 0 minus 5 is negative 5. So therefore, 1 times negative 5 is negative 5. So y is negative 5. Therefore, our y-intercept is 0, negative 5. So for part C, it asks us to find the equation of the axis of symmetry by averaging the zeros. So first off, when you think of a parabola and you think of its x-intercepts, the axis of symmetry is what cuts your parabola in half and makes it symmetrical. So if we want to find the axis of symmetry by averaging those zeros, we really want to take the zeros, which are negative 1 and positive 5, which we found from part A. We want to add those together, which becomes positive 4. And by averaging, we're going to cut them in half, so we're going to divide by 2. So therefore, our axis of symmetry is where x is equal to positive 2. And remember, we want to make sure that that's an equation of the line. So for part D, we want to find the vertex by substituting that x value from the axis of symmetry into the function and finding your y value. So again, nothing new. We've definitely done this before. So we can go ahead and say that y is equal to 2 plus 1 times 2 minus 5. And remember, we're plugging this back into the original function. We're just substituting that value of x. Y is equal to 2 plus 1 is 3, and 2 minus 5 is negative 3, so therefore y is equal to negative 9. So therefore, our vertex is 2, negative 9. So now we have x-intercepts, we have a y-intercept, we have an axis of symmetry, we have a vertex, we have enough information to sketch this parabola. So go ahead, let's graph it. We'll graph our x-intercepts first. Negative 1 is right here, okay, which you can't see because of this little bar. I apologize. Negative 1 is right there. Positive 5 is 1, 2, 3, 4, 5. Our axis of symmetry is the equation of the line where x is 2. So we can draw that dashed line in. We know that our y-intercept is 0, negative 5. 1, 2, 3, 4, 5. And we know that our vertex is 2, negative 9, 6, 7, 8, 9. And once that is all done, if you'd like to draw a mirroring point on the other side, you can. But other than that, we have enough information to sketch the parabola. Make sure there's arrows on each end because the domain can go on for forever and ever and ever and ever and ever. And in terms of graphing, we look pretty darn good. So now for part F, it says put p of x in standard form. That is just foiling, or some of us like to call it double distributing. It's up to you. But that just means that P of x is equal to x plus 1 times x minus 5. This is in standard or intercept form. And remember, standard form is that ax squared plus bx plus c. So we can distribute x to both pieces. That becomes x squared minus 5x. We can distribute 1 to both pieces. That becomes positive 1x minus 5. Combine like terms, which are your two middle terms. And therefore, in standard form, P of x is equal to x squared minus 4x minus 5. And that is your answer key to example number 1. You have x-intercepts at -1 and 5. You have a y-intercept at 0, 5. You have axis of symmetry where x is equal to 2. You have a vertex at 2, -9. We put it all together just like we did in class and sketched our parabola. And we were able to FOIL and work backwards and figure out this parabola with its equation in standard form. So go ahead, get started on example 2, and I'm pretty sure you'll see me in a few minutes to go over the next answer.